Welcome to the channel Unknown Physics. So today we are going to continue the topic mechanical properties of solids. I have done two videos in this topic. If you have not watched, I am giving a link in the description. Please do watch and continue for a better understanding. So what we are going to look today? Stress and its type. The rigid body, which we have seen in our first video. So the rigid body is a useful idealized model by the stretching, squeezing and twisting of a real body when forces are applied are too often important to ignore. We want to study the relationship between the forces and the deformation for each case. So for each kind of deformation, we will introduce the quantity called stress that characterizes the strength of force causing the deformation on a force per unit area basis. And the quantity called strain describes the resulting deformation, which we'll see in our next video. So what is stress? When a force is applied, the size or shape of both may change due to the change in the relative position of atoms or molecules. This information may not be noticeable to our naked eyes, but they exist in the material itself. When a body is subjected to such a deforming force, internal forces developed inside this is called as restoring force. So the restoring force per unit area of a deformed body is known as stress. So stress is given by the formula restoring force by area. Unit of stress is Newton per meter square. For force it is Newton and for area it is meter square. So it is Newton per meter square. Whereas in CGS system it is dyne per centimeter square and in SI system it is Pascal. And the dimensional formula is m L power minus 1 T power minus 2. So let us see the types of stress. First is longitudinal stress. Let us consider a body of shown in the figure. When forces may act on the system, the center of mass remains at the rest. The body gets deformed due to these forces and the internal forces appear. So, the normal stress or longitudinal stress over the area is defined as perpendicular restoring force, that is perpendicular to the area per unit area. Longitudinal stress can be classified into two types, tensile stress and compressive stress. So longitudinal stress is given by the formula perpendicular restoring force by cross-sectional area. That is the area of the object. When forces act on the two sides of a delta A push each other, then delta A is pushed by equal and opposite forces at the two ends. So in this case, delta A is said to be under compression. Then the longitudinal stress is called as compressive stress. Other thing is tensile stress. Internal forces on the two sides of a delta A may pull each other. That is, it is stretched by equal and opposite forces. Then the longitudinal stress is called as tensile stress. Next is shearing stress. So shearing stress is defined as the tangential restoring force that is tangential to the area. You can notice in the GIF, right? So tangential restoring force per unit area is known as shearing stress. This volume stress. This happens when a body is acted by force which is everywhere on the surface, such that the force at any point is normal to the surface and magnitude of the force on a small surface area is proportional to the area. So for instance, when a solid is immersed in a fluid, the pressure at the location of the solid is P. The force on any area is delta A. So force is given by pressure into delta A. So volume stress is the pressure change. I have a question for you guys. So the question is find the SI unit and dimensional formula for volumetric strain. So if you know the answer, please do mention in the comment box. So that's it for the day guys. So in my next video, I'll cover about the strain and types of strain. Till then, bye bye everyone. Have a nice day.